In this video, we have two integrals to evaluate. They both involve the exponential e to the x. Now for the first one, probably the best way to do this is just to expand the numerator. We have 1 plus e to the x, quantity squared. So it's a square in a binomial. Be a 1 there, then double the product, it'd be 2 e to the x plus the e to the x squared. You can write it as e to the x quantity squared, or you can write it as e to the 2x. And then we have the e to the x in the denominator. Then we go ahead and just simplify this. Go ahead and divide through by e to the x here. So 1 over e to the x, I can write that as e to the minus x. Got 2 e to the x divided by e to the x. The e to the x cancels, so this will just be a plus 2. And I got e to the x, and then e to the 2x is simply 2 factors of e to the x, so one of them will cancel. I'm going to divide these out there and give me e to the x. And then we can just integrate here term by term. The integral of e to the minus x, e to the minus x, and divide by the derivative of minus x is negative 1, so this will be minus here. Integral of 2 with respect to x is just 2x. The integral of e to the x is just e to the x. And you can easily check these by just taking the derivative. Derivative of e to the minus x is e to the minus x times, using the chain rule, derivative of negative x is minus 1 times the minus gives you this. Derivative of 2x is 2. Derivative of e to the x is e to the x. And we have the constant of integration. And that's the solution, the integral for the first one. Or should I say the value of the integral. Now for the next one, this one we'll do it using a U-substitution. So let's let u equal to 1 plus. We'll let u equal 1 plus e to the x. Then du would equal to, derivative of 1 is 0, derivative of e to the x is e to the x, and this will be dx. Now we convert the integral to one involving the variable u. Okay, so equal to, in the numerator we have e to the x dx. So here, e to the x dx. That's your du. In the denominator we have 1 plus e to the x, but that is u. That's u to the 10th. Let's rewrite this as u to the minus 10. Take it to the numerator, the sign changes for the exponent, and this will be du. Now it's simple integration with respect to u. So u to the negative 10, we add 1 to that exponent, that gives me a negative 9, and then we divide by that. So we get that. Then it's plus the constant of integration. And then we go back to the original variable then. Replace the u by 1 plus e to the x. And that's taken to the negative 9 power. And that's divided by negative 9. And you got the constant of integration. And again, this is one you can easily check if you have time, just to practice the derivative. I take the derivative of this expression here. That means negative 9 multiplies the coefficient over here. I got negative 9 over negative 9. Cancels to a 1. Then I subtract 1 from the negative 9. I get negative 10. So I get a 1 plus e to the x taken to the negative 10. Take that to the denominator, and of course using the chain rule I have to take the derivative of this expression. And that would give me an e to the x in the numerator. And to make it look like the original integral or integrand, take it to the denominator, it changes back to positive 10. So again, derivative of this constant, of course, has the derivative of 0, so negative 9 times over the coefficient, negative 9 over negative 9 is cancels. Subtract 1, negative 10, take it to the denominator, and then using the chain rule, take the derivative of 1 plus e to the x, gives me e to the x, and of course it gives me the original integral. Thanks for watching. We'll see you next time.